Good morning, everyone. John Pendleton, your trainer today. Thanks for joining. Just give us a few minutes and we'll get started just a couple minutes after 9 o'clock. Thank you. Good morning, everyone. Thanks for joining today. We're going to cover some of the service procedures that we can use on geothermal units and some of the flow centers and things like that. Probably about a half hour, 45-minute webinar today, so not a super long one for you. So we'll go ahead and get started. Feel free ask any questions as we go along. There's a little questions tab on the control panel there. You can just ask a question there. When I see it pop up, I'll get to it. So it may not be immediate, but I'll get to it as soon as I can. So this is me. I'm the senior trainer. I also work in tech support, handle site visits and stuff like that. So really, I do more of the training now. Not so much in tech support, although I do help out. So you may hear me on the phones from time to time. I've been with Enertech for about 8.5 years now, and I was a service technician, like a lot of you guys in these trainings. I grew up in the industry. My dad was a service technician, and so I've been doing it pretty much my whole life with him. So I've got well over 30 years of experience, working on it in the field. So I've been there, I've done that. I try to pull some of that service knowledge into some of these trainings and, just try to let you know some of the things that I've seen and how I've kind of handled them. So that's just a little bit about me. If you do need to contact me, that is my email address, john.pendleton@enertechgeo.com. And then there's my direct line is the first number. And if you need tech support, the 664-5860, excuse me, that will call back directly to the tech support pool, and we'll get a hold of one of the 4 or 5 guys we've got back there. So we'll go ahead and get started on some of the procedures, some of the tools that we will use. So if you ever have a problem with a pressurized loop and you have problems with it losing pressure, I'd recommend purchasing this tool, and it's called we call it a loop gooser or a geo gooser, and it's an easy way to add pressure to a loop when you have a pressurized flow center. So obviously, with the pressurized flow center, you've got to have pressure so the pumps don't cavitate. So it's got a little needle on it, and you can kind of see it. It's kind of covered here, but that'll go into your pressure temperature port. You hook up a garden hose to it. Then it's got a pressure gauge. So when you shut the valve or open up the valve, you can see the pressure. Excuse me. When you close that valve, you can see the pressure in the loop field. Normally, a loop field somewhere between 40 and 60 psi is where it's normally at. It can run lower than that, We just don't want it to run into a negative pressure when we come out. So sometimes we see a loop go flat when we're switching from season to season. In the winter, the pipe is cold, so it constricts, and so your pressures are higher. And then in the summer, when that pipe warms up, it tends to want to relax, and you drop pressure. You don't really drop fluid, you just drop pressure. So if that happens, then you can use this gooser to go ahead and build that pressure back up. Basically, it's going to use city water pressure to build that pressure back up. Normally, it doesn't take a lot of fluid volume to build that pressure back up. It's usually, once the pressure gets to zero, it kind of stops there. So it doesn't really take a whole lot to get that pressure back up. If you need to replace a pump on a flow center, most of our flow centers now have isolation valves, and you can isolate the flow center from the loop field, and then you'll have a little bit of water come out, but you can access through your flush ports on the flow center, which are located, those little circles here. You can put a little cam adapter or some kind of adapter in that flush port, and you can drain that into or put it into a drain. So you can, basically, you're going to lose the fluid that's, if there's shutoff valves here on the side of the flow center, that's going to isolate the loop. So then you just have this little small standing column of water there. And then you'll just have a little bit of water before these little black pumps that are listed there. So you can drain a little bit of water out, and then you can pop off the pump and take that pump out. If you ever have a flow center that's leaking right on startup, I would always check your connections coming into the flow center. Sometimes if we don't get if we don't get these pipes coming in straight, they want to kink a little bit or off center just a little bit. And these are double O-ring fittings, and the double O-ring doesn't want to seal it. So if you ever notice that it's leaking out the back of the cabinet on a brand new install, definitely look at your connections coming into the top of the flow center and make sure that it's not leaking out of those fittings. It's kind of hard to see when you do get it and you look down in there, it doesn't look like it's leaking from that fitting. So I would say that if it's a brand new flow center, it's probably not a flow center leak. It's probably one of the fittings or something like that. So, but we can change pumps without taking down the whole system. Basically, once you put the pump back on here, you're going to have a garden hose that supplies some water so you can fill this back up, and then you can kind of push the air back out on the return side. Again, this is a pressurized flow center. This is a three-way valve that we're showing here on the side. We've kind of got a little view below that picture here. You got your front flush port, and then your 2-year loop and 2-year unit. Inside of there, if you ever see water kind of leaking out here, then there's some seals inside of here that could be an issue. I will say that if those seals are an issue, you probably have a water quality issue. And so we'll probably have to check that water because what's happened, it's eating away at these Teflon gaskets that are in there. There's 3 of them. There's this round one on the side down here, and there's 2 on the end of that valve there. Basically, there's a snap ring. If you remove the snap ring that's located there, then you can put a kind of like a little square drive on that and just move it back and forth while you're kind of pulling a little bit, and you can slide that whole piece out. Obviously, you want to drain down any water from the loop field before you do that, because you're going to have a mess if you don't. So make sure you drain the loop field down, and then you can access these gaskets. We do have a gasket kit that you can purchase. If it's under warranty, if the flow center is under warranty, I would not probably replace the gaskets. I'd probably just replace the whole flow center, unless for some reason you don't want to change it. Maybe it's in a difficult area or something, I don't know. But if it's under warranty, I wouldn't change the gaskets. But if it's out of warranty, we do have the gasket kit. And it'll basically be the 3 gaskets and a new snap ring. So if you break the snap ring, don't freak out too bad, because we'll give you another one. If you ever have a problem with, maybe in cooling mode, and you've got an open loop, you're having problems with high discharge pressure, and you've got good water flow, or it's not transferring heat very well, maybe you've only got about a 2 or 3 degree temperature difference on the source, we have a calculation that we can do and figure out if that heat exchanger is scaled up. And it can happen on the load side too if you have bad water quality. So we can check it either or, but normally it's going to be on the source side on an open loop system. And so whenever you guys go out to a job with an open loop, that job every year you should run this calculation. Over time, it's going to need to be cleaned, which is why in an open loop we use a Cooper-Nickel heat exchanger, because it's more robust and can handle some of the chemicals that we use to clean it, and we know you're going to have to clean it. So this is a good calculation to keep in the back of your mind. This is one of those things that you get out to a job, you can't figure out what the problem is, and I mean, you've checked everything, and then you pull something like this out, and you can figure out what the problem is. You're not transferring heat. So it's basically a heat exchanger scaling calculation. So in heating mode, we're going to take the average fluid temperature minus our evaporator temperature. In cooling mode, we're going to take the condenser temperature minus the average fluid temperature. The evaporator temperature is your suction pressure converted to temperature. So you're going to use your pressure temperature chart. And the discharge saturation temperature, or discharge pressure converted to temperature, that's going to be your condenser temperature for your cooling scaling calculation. Now we'll go through an example here of some scaling here in just a second, so you don't have to be like, what the heck's going on? But basically, the result of this calculation should be somewhere between 5 and 15. Anything over that, and it's starting to get scaled up. Anything over 20, and it needs to be cleaned. So it's, if it was 17 or 17 and a half or 18, if you're not there really for that issue and you don't really have time to do it, it's not mandatory. But if it gets over 20, you're going to need to clean that heat exchanger. So here is an example of what we're trying to do here. So the first thing we're going to do is we take our entering source water temperature. So entering water temperature plus your leaving water temperature. Take those two numbers and add those together and then divide by 2. So if it's 50 and 45, that gives us 95 degree water. We're going to divide that by 2, and that gives us 47.5 degree average water temperature. So water in, water out, add them together, divide by 2. Next, we're in heating mode. So we're going to take our suction pressure, which we're going to tell you it's 85 psi, and we're going to look it up on the pressure temperature chart. So 86 is close enough, so that would be 25 degrees. So we kind of got to remember that number. So then what we're going to do is we're going to take the 47.5 minus our 25 degree saturation temperature, and that gives us a number of 22.5 degrees. So again, we say anything over 20 and it needs to be cleaned. What you'll normally see when you start to get scaled up is on an open loop, we're normally about 14, 16 degree temperature difference. What you'll see is your temperature difference is very narrow, maybe 10 degrees or 8 degrees, when you're in full load. So you'll see that your temperature differences are normally not where they should be. Your heat of extraction may not come out properly. So it's a real quick way to check for scaling on that heat exchanger. Here's another example. We have 80 degree entering water temperature and 90 degree leaving. So we're in cooling mode now. So again, same calculation, take your entering and leaving water temperatures, Add those and divide by 2. So 170 divided by 2 is an 85-degree average water temperature. Then we're in cooling mode. So now we're going to take our discharge pressure, and normally you wouldn't see 185, but for this calculation, that's just what we're going to use. So we'll take our 185 and look at what that converts to temperature. And that tells us it's 65 degrees. So now we can take the 85 minus the 65, and that gives us 20 degrees. So again, normal is 5 to 15. Over 20 is suspect of scaling. So here, we would know that, it's scaled up and it needs to be cleaned. I may want to ask, what do I clean it with? Well, there's numerous things you can clean it with. We have some cleaner made by Fernox that you can use. You can purchase it from us. It depends what type you get. It could be a liquid, it could be a powder that you put into a liquid, but you can pump it in, mix it throughout the system, take it out, and then I would recommend, flushing that through there for a little bit. You can also use, if it's more of a bacterial growth inside of there, once you open that pipe, if you put your finger inside that pipe and it's real slimy, then you've got bacterial growth. And then I would use more like a bleach. But if you've got like minerals, the lime scale buildup, you can use CLR. You can use a diluted, I think it's more like a muriatic type acid. I've always known it's called sizzle. A lot of plumbers use it to clean toilets out. You can use that, and you'll basically just going to flush that through your boiler drain valves that you have on your open loop system and circulate fluid through there and clean that heat exchanger out. Then you can, after you've got it clean, you can actually redo the calculation and make sure that number is dropped within your normal range. So one of probably the biggest maintenance needs on an open loop is, is using this calculation and cleaning, keeping that open loop system clean. So again, in heating mode, we're going to use suction temperature, so suction pressure converted to temperature. And in cooling mode, we're going to take our discharge pressure and convert that to temperature and just do the math. It's a pretty easy calculation, but it's just one of those things that you don't use every day. And so you might forget about it, but it's always a good little service tool to keep in the back of your mind. It's always nice when another technician's been out or numerous other companies have been out on a system and can't figure it out, and you pull something like this out of your bag and it's actually the problem. It makes you look really good, I can tell you that. It makes you feel good too, like you're kind of actually learning something. So if you need to clean the heat exchanger, here's a great way to do it. Just get a little 5-gallon bucket from the hardware store. You can get like a little giant pump. You can use a condensate pump. There's numerous pumps out there. You can use whatever you need. It doesn't have to be real big. We don't have to move 30 GPM through this thing. We just need to move the fluid through it. Probably the slower the better, to be honest with you, so that chemical can get in contact with the pipe. And you may want to put water or some fluid with cleaner in there and let it sit for a little bit as well to try to break up some of the bigger stuff that may be stuck on there. But whatever you do, I would always pump in the opposite direction so you get some real turbulent flow throughout that heat exchanger. It'll help clean it a lot better. I know that back in the day, we had some Econar, we have some old Econar equipment and we acquired them, but I know Econar used to do some freeze cleaning, and we don't recommend freeze cleaning. Too many things can go wrong, and if you bust a heat exchanger, it's never a good thing. So don't freeze clean, just use some CLR, some muriatic acid, or some bleach, or whatever you feel. If you have any questions about what you should use when you get out there, just give us a call and we'll try to figure out what we think maybe is in there, and then I'll give you some recommendations on what to use to clean it. But basically, you're just going to run that pump, and you'll see in that 5-gallon bucket, a lot of times it'll be more of a white chalky debris that comes out of the heat exchanger. And so you'll start to see your water in your 5-gallon bucket get clouded up. You can change that water out, put some more cleaner in there, and whatever you do, once you get done cleaning it, make sure you just run some fresh water through there so we can get some of the chemicals that might have stuck to the walls. We can rinse those all out of there. It's going to vary how long it takes to clean it. It's really just going to depend on how much it's scaled up and what it is. If you ever have a problem with a closed loop, water quality issues, and you need to get a sample of your fluid, or if you need to check antifreeze levels or something like that, on a pressurized closed loop, it's a little bit more difficult. On a non-pressurized closed loop system, it's pretty easy. On the non-pressurized, there's a cap right on top of the flow center, and you can just take that cap off and dip some fluid out of there. On a pressurized system, it's a lot harder. Basically, you're going to need a needle to put in a PT port, and with an open end on it, so you can put a bottle around it and you can fill it up. And then I would recommend using a loop gooser, or if you've got some other way of pressurizing up a loop field, maybe you've got a pump sprayer with a needle on it, and you can use that pump sprayer and pump it up with pressure to pressure it up. I've seen that done before, but you're going to have to put something in to pressurize it and something in there, or an open needle, so you can remove the fluid. Go ahead and turn the system on so the pumps are running, and attach the loop gooser or something to build the pressure up in the water out PT port, and open up the valve so you keep some pressure on the loop. Go ahead and put the needle with nothing on the end of it into the entering water PT port, and it'll start spraying water out of that little hole, that needle back at you. So have a bottle ready when you get it in there, and fill up the bottle with fluid, however much you think you need. If you ever have to send a water sample into Enertech, we can test it. We do have test kits now available, so you can test it in the field. But if for some reason you want us to check it, just make sure that I get about 16 ounces of water. So a little water bottle full will be fine for me. If for some reason the homeowner's real picky and they want it tested through a lab, I do have a lab here in just close to us over here in Illinois that I can send your result or your water sample to, and they'll send me the results. If you're going to do that, give me a call, and I'll give you the address to ship it to, and then I'll get some job info so that I know who to contact once I get the results back. Once I get the results back, I'll take a look at them and I'll give you a call, and I'll send you the results as well. And that way we've got proof to the homeowner. If you're just curious about it, it's a Fernox test kit with some test strips. And I don't know, I think it can do like 100 or 150 tests. So you can keep it on your truck. And I would always test water on a geothermal unit, always. So it's easy to test, it's quick. There's instructions in the test kit that'll tell you how to test. It's not rocket science at all. So you got to match up colors is what you're going to do. So I would recommend getting one of those test kits and just keeping it on your truck. I think it costs maybe $100 somewhere around there. And it'll have all the instructions and let you know what we are looking for when we're testing it. After you've got your water, you can check it with a hydrometer, if you're looking at antifreeze levels. You can also use refractometers, which seem to not break as easily as the hydrometers. I don't know if you've used hydrometers in the past, but it's basically a glass tube that they tend to break, so they're hard to keep on your service truck. I probably broke 6 or 8 of them, and I don't even work in the field anymore. So I like to use the refractometers. They're pretty dummy proof. You just put a drop of water on a sight glass and you look through the viewing window and it'll tell you what the level of it is. So propylene glycol and ethylene glycol, you can buy those refractometers at automotive stores. And the methanol and ethanol, which is alcohol based, you can usually go online and look for a methanol refractometer, and Amazon, whatever, what may have you. I think VG makes some refractometers. I think that's the brand that I have here at Enertech, is a VG brand. So if you're interested in that, we do have hydrometers that we sell at Enertech. Again, they're glass, so you got to be kind of careful with them. We have this chart in all of our IOMs, and it's basically antifreeze. And if you look on this top line, the one that goes up, that's for propylene glycol. Propylene is heavier than water, and alcohols are way less than water. So water would be 1.0 here in this chart. So right here through the middle. So propylene glycol is heavier than water, and your alcohol-based antifreezes are lighter than water. Normally, we're looking for somewhere right around 15-degree freeze protection. So on a hydrometer, depending whether you have ethanol or methanol, you're going to be in this 0.97, 0.98 range here. And then propylene glycol, you're going to be about a 1.035 or so, or 1.03 for your 15-degree freeze protection. You don't have to have it exactly at 15 degrees, but especially with propylene glycol, it's hard to pump it when we get over a certain percentage. So putting too much in, we start getting into like a 0-degree freeze protection. So there's 1.045 area, and you're gonna have a hard time. You're gonna start taking out pumps because propylene glycol is sugar-based, and so it's thick, and it's not as, it's kind of viscous there. So it's a little bit harder on the pumps. It's also harder to transfer heat. So if the more antifreeze you get in there, the less, it's harder to transfer heat, and it's harder on the pumps to move it. With methanol or ethanol, alcohol-based, those, you're not really going to get too much in there as far as heat transfer or affect your pumps, because it's, it's lighter than water, so it's got great heat transfer. But it gets very flammable once you get over about 25%. So we've got to really be careful with our percentages there, because it could be flammable. So we're going to be somewhere again around our 15-degree freeze protection. So here's a hydrometer here on the left side with that arrow, and we're looking at an alcohol-based here. Again, water. If this were to float and there was no antifreeze in it, it would float right here at this 1, because it would be straight water. Now, these are kind of weird to read. So if we just look at this chart where this arrow is pointing, it looks like, on here, it looks like if we look at this, we see 0.9 and 0.8. So I would think 0.85, right? Well, there's really a hidden 9 in front of this first 9 here. So that's 1.0. This is really 0.990. This is 0.980. This is 0.970, and so on. So it's kind of weird. You would think, well, I'll look at 0.85. Well, 0.85 would be way down here on this chart. So it's really 0.985. So we come up here to 0.985, follow it over, and you can see that's about 17.5 degree or 18-degree freeze protection or so. It's a little bit light, but not, we're not really, that's probably close enough. And that would be, that's the methanol there. If we had ethanol, we'd have our freeze protection about 26, 28 degrees. So if it's ethanol, that's our ProCool. Then we also have methanol. So again, there's a hidden 9 in front of these numbers here on that hydrometer. So it's kind of weird how to read them. And if you don't use them a lot, you kind of don't, it's hard to remember that. So if you can't really get it figured out, you're not really sure, just give us a call. I mean, we deal with these quite a bit. So once you start working on geo more and more and more, you'll start to pick up on the little things. But it takes a little bit of time. Not gonna lie, they're not real intuitive on how to read them. That's why I really do like the refractometers. I mean, you look through a sight glass and it tells you what it is. It's pretty self-explanatory. How to detect the type of antifreeze that's in the system? A lot of times it's really hard, and you don't want to really mix antifreeze, different types of antifreeze, especially when you mix a alcohol and a glycol. They don't mix very well. So the specific gravity in alcohol weighs less than water, and glycol weighs more. So if you put a glycol hydrometer into water that has alcohol in it, it's going to sink to the bottom almost immediately. If you put a methanol hydrometer into glycol, it's just going to float at the very top. Basically a 1. Color, some of them do have colors, but not always. A lot of alcohols, especially methanol, will not have a color. It'll just be clear. A red or a pink is usually a glycol, but I've also seen blues and greens and glycols as well. But blue and green are usually alcohol. The green, what we have ProCool, and it's green. But that, again, it doesn't mean just because it's green, it's an alcohol base. A lot of times I can base it off of how it feels. A glycol will feel really slippery. Like when you get it on your finger, it'll feel real slick. Also, as it dries, your finger will be a little bit sticky because that's the sugars in it. So it'll be kind of tacky. Alcohol, when you put your finger in it, it'll have almost a cooling effect when you pull it out of the water because it starts to evaporate. And so it'll feel kind of dry and kind of cool your finger off. Smell is a very good way to tell for alcohol because it's going to smell more like almost like a rubbing alcohol or an isopropyl alcohol. A glycol will smell a little bit sweeter. I guess you could taste it too. I've never tasted it, but with it being sugar based, it will have a sweeter taste to it. But I don't recommend tasting it. The best way to know if you can't tell by feel or smell or what have you is to use a hydrometer or a refractometer. It'll kind of tell you. Usually you can tell pretty quickly if it's a alcohol or a glycol. I smell them and feel usually works probably the best for me on figuring out what's in it without a hydrometer. Microchannel coils, if you need to clean these, they're not the easiest to clean. It's a water-only cleaning process. If you do need to use a solution, you got to check the cleaner to make sure it has a pH between 5 and 9. It doesn't contain chloride, sulfates, copper, iron, nickel, or titanium. If you give us a call because you're not real sure about a product, just let us know. You're not really supposed to use coil cleaner on them. They're acid-based. You can use, like a dish soap. The best way to clean a microchannel air coil is to keep it clean. It's hard to really clean them with water in place because they're usually inside the home. So the best way is just to keep it clean. And don't use them during construction. Drywall dust gets stuck in these passageways and it's really hard to get it out. If it did get some drywall dust or it's, you got an old cat lady or something, you may want to use a shop vac and see if you can pull it off with a vacuum. But whatever you do, you can clean the face with like a pressure washer, but you're gonna need to make sure you're always at a 45 degree and you don't exceed and get too close. You don't want to exceed 900 PSI. I wouldn't even come anywhere close to that and stay at least 12 inches away. So that kind of causes us not to be able to clean the coil in place. If it gets so dirty that, you know, it becomes a problem, you're probably going to have to remove the refrigerant, pull the coil out of the unit, and take it outside and clean it. So again, that's why we say don't use them during construction. For one, it can void your warranty. So, and for two, if you get any kind of lacquer or paint or drywall dust, you're gonna have a hell of a time trying to get it clean. So the best way to clean a microchannel coil is to not have it get dirty in the first place. We do have a microchannel coil repair. It takes a little bit of knowledge on how to braze on aluminum. Basically, if you ever have a leak in your microchannel coil, you know, in the middle of it or what have you, basically what's going to happen is you're going to end up cutting that section out and filling those holes in, and then plugging that hole with a piece of aluminum so the air just doesn't dump through that hole, and it's going to bypass that little section. So we do have a video online that you can watch. I'm not going to get real in depth on this because the majority of the air coils are under warranty. So if it's under warranty, I wouldn't make this repair. And really the microchannels are very reliable. We've had a few leaks here and there, but the majority of them are very reliable. So this is more of, just keep it in the back of your mind. If you have a problem and you need to repair that coil, there is a kit we can get you, and we'll get you the video at that point too. Because if you feel comfortable brazing on aluminum, and you know, go right ahead. But this is more of a last resort thing that I would do. So I just like to mention that we do have a coil repair kit that you can get. Hang on one second, my computer froze up here. Bear with me, boys. I'll be right back with you. There we go. All right. So if you ever have a problem with you've got a leak and you think that it's in the heat exchanger, so the coax source heat exchanger, or if you've got a water to water, it could be the load heat exchanger as well. So if the unit will still operate, it's got enough refrigerant in there, or you can put some refrigerant in there and let it run, what you can do is turn the three-way valve on the flow center, which is, oh, sorry about that. Just trying to get my highlighter. So you can take your three-way valves, you can close those off and disconnect the pumps so that they won't run. And we'll run it in cooling mode. And you can put a little pressure gauge in your PT port. So basically what we're going to do is we're just going to build that discharge pressure when we're in cooling mode. So if there is a leak, let's say you've got 20 PSI normally here in your loop. With the pumps off, the pressure is not going to really change. It shouldn't. So once we start to build that discharge pressure, if we think the leak's in a heat exchanger, it's going to push that refrigerant into the water. So in turn, if we had 20 PSI pressure on this pressure gauge, then that pressure is going to start raising. If you see it start raising, then we know there's a leak in the heat exchanger, and it's pushing the refrigerant into the water. If the unit will not run, maybe the compressor is dead at this point because it ran with no refrigerant or what have you, basically you're gonna remove any refrigerant, if there's any in there, pump the system up with nitrogen, and again, do the same thing. Put a pressure temperature gauge or a pressure gauge in your PT port, and don't be afraid to pressurize up anything on our refrigerant side up to 500 psi. It's all rated for 850 psi. When I'm in our model shop testing air coils or heat exchangers, I usually test somewhere about 400 to 450 psi. You know, sometimes real small leaks, you can't, you know, find them at 150, 200 psi. So don't be afraid to put some pressure on there. You know, these systems with the 410, they're rated for almost 1,000 pounds. I think ours are like 850 or something like that. So don't be afraid of, you know, blowing something up. It more than likely is not going to happen. I've never had it happen. So, but basically you're just going to, again, put the pressure gauge in there, pump it up with nitrogen and see if it pushes nitrogen into your water. It'll go up pretty quickly. It's a real quick way to know. You know, don't just say, well, I've looked over the whole system and I can't find it anywhere else, so it has to be in the heat exchanger. Because for one, the heat exchangers are not easy to replace. So I wouldn't want to just go willy-nilly replacing a heat exchanger. I would want to find out for sure that that's what it is. If you have a braze plate and you think it got frozen or something, on a braze plate, normally you can tell because it'll be swollen in a certain area, and then you know it's breached. On a braze plate, it usually shows pretty quickly too. It'll usually dump pretty quickly. The coaxial heat exchangers, for one, they can handle freezing a little bit better, and sometimes it'll just be a real small leak and it's really hard to find. So a lot of times that's due to maybe there's a problem with the coax and it tend to etch away at the heat exchanger slowly over time. How to find a leak in an air coil. One thing that is nice about the microchannel air coils is that when they get a leak on them, they'll usually leak oil along with it. And if you've seen those microchannels, they're kind of a light silver color. When they get oil on them, they'll be stained, a darker silver, maybe even a gray color. So that's usually pretty easy to tell because it's been leaking oil on it. If you've got access to it, you can just look at the face of it. We bring a lot of these air coils back when they do leak. Almost every time there's an oil spot on them. So what I have seen on the coils that I have brought back before you take, you know, telling you how to find the leak, one thing I've noticed that we had I wouldn't say a rash, but we had coils leaking, and so we started bringing them back, and they all were pretty much leaking in the same spot. If you look at this slide here, it's kind of hard to see, but here you've got the U-bends, and then on the other side, you've got almost like a header, and then obviously you've got the four corners. In one of these four corners of the air coil is normally where I see the leak, and it's right up against the plate there. And so that's where I would check first, is check those four corners. And it's going to be a fairly small leak. And I've also found that, you know, at 300 psi, I can't hear the leak. You know, I've got just the air coil sitting on a bench in the lab, so it's a lot easier for me to put my ear down there and listen. And at 300 psi, I can't hear it. At 400 psi, it's almost like it breaks it loose, and you can actually hear it leaking. So that's what I would always check first, is those four corners to see if it's leaking, and look for oil in those four corners. If it's not leaking there, we have a fitting that this coil is all aluminum. So it's got a little stub that's pressed in, and on that stub, there's like a little black, looks like a black piece of plastic, and there's aluminum to copper going together there. And so we put that plastic over there so air can't get to it. We got dissimilar metals, but I've seen where that pressed fitting or that braze fitting between the aluminum and the copper has leaked. Those are the two areas that I would look at, those corners of the air coil and the connection where it goes into the air coil. Those are the two biggest areas of leaks that I've seen. The majority of the time, this air coil is pretty reliable, so usually not a big deal. But if the unit does operate, basically you're going to kind of do what we did on the source and cooling mode. We're going to run the unit, but we're disconnect the blower motor, and we're going to build that pressure on the discharge and heating. and take your leak detector in the cabinet and see if you can get any leakage across there. If it doesn't have any refrigerant, again, pressurize it up with nitrogen, and then you can use soap bubbles. I will say soap bubbles do not work very well on the microchannel air coil. Sometimes you can get it to bubble up, but that microchannel air coil is pretty thick, and so a lot of times it doesn't want to bubble up. When I think that there's a leak on one and I just can't find it, and I've got the coil back at the office, I've got a tank. I'll drop it, I'll plug up the lines, fill it with nitrogen, and I'll dump it into a bath of water and look for air bubbles. But the easiest way is to use a leak detector and then look at the coil real closely and look for oil. We've got an old Johnson Controls plug-in electronic leak detector that we use that works real well. I've used in the past. I think I had a TechMate that I use quite a bit that I trusted. So it's usually just finding one that you trust and know how to use it. Sometimes those electronic leak detectors can be a little touchy. So again, soap bubbles just don't work the best. Be careful when you're servicing these 410 systems. I just like to mention, I mean, we're pretty used to working on 410 anymore, but the POE oil loves moisture. So if we ever ship you oil for the refrigerant circuit, it's in a metal container because it can actually pull moisture through plastic. It's very hygroscopic, and it just loves moisture. So when you're servicing a system, make sure that you don't cut the system open and then go, well, I got to go get a filter dryer from the supply house, and while I'm at it, I'm going to go ahead and grab lunch, and I'll be back this afternoon. Don't leave that system open because it'll start pulling in moisture, and it'll get trapped in your system. So try to keep the system open at a minimum. Never unbraze a component from the system. Always remove it with, cut it out of the system. If for some reason you feel like you need to unbraze it, then you need to put nitrogen on it. We use nitrogen when we're brazing, so we don't get that buildup on the walls of the oxide buildup on the walls of the refrigerant lines. With the 410, with the higher pressures and the POE oil, if we don't braze with nitrogen, it tends to scrub the walls of the refrigerant lines, and it breaks all that black soot loose, and it takes it right back to the TXV, and it restricts the TXV. It can also plug up your filter dryers as well, but the easiest way to not have that happen is to make sure you always braze with nitrogen and to cut out all of your components. Obviously, we want to charge in a liquid, and we'll normally use subcooling when we're charging it. If you don't have an IOM, you're trying to charge one of our units, a good thing to always remember is we can get close to 10 degrees superheat and 10 degrees subcooling. We should be pretty good. Now, we're pretty good about listing what our ranges are in the IOMs, but if you don't have one or you've got an older unit, just try to remember 10 and 10. 10 degrees superheat, 10 degrees subcooling. Again, never torch out a component. Always bleed nitrogen when brazing, usually about 2 pounds or so. And replace the filter dryer when making any repairs in the system. If it's warranty, we'll always send you a filter dryer. I always hate it when I get warranty parts back and I've got an unused filter dryer. Maybe you've used one that you guys like to use better, and that's fine, but it just makes me a little leery when I get it back. Obviously, it's there to keep any moisture out of the system, and it's really the only way to really collect that moisture if it gets into the system. So make sure we're using a bi-flow filter dryer and don't torch it out. The second stage solenoid unloader, if you need to test that, if you're not sure if the compressor is going into second stage or not, our units run about 67% in first stage, and then it adds the rest of the second 33% in second stage. So normally if we have an amp meter on our compressor, high voltage line there, it should normally go up about 3 to 5 amps, or about 33%. So you can cycle the unloader. Either you can disconnect it from the compressor and plug it back in, or you can remove the Y2 coil and then re-engage it, and you should see that amp draw go up or down. If you don't get the expected results when you do that, you can jumper R to Y2, shut the system down, at least the compressor and the fan and all that, and give it just jumper R to Y2. Nothing will really run on a Y2 call, except it will energize the solenoid on the compressor. So you can kind of listen and see if you can hear a click on the compressor. If you don't hear that, you can disconnect the power to the unloader, remove the molded plug. It's two small blue wires that go to that plug on the compressor, and you can actually check the resistance of the unloader solenoid at the compressor. Normally the resistance is going to be 32 to 60 ohms, depending on the temperature of the compressor. So if the compressor is real hot, you may want to wait for the compressor to cool off before you do that test. You can also check the molded plug for voltage output. So if you give it a jumper R to Y2, then you should have 24 volts coming into it. But it's actually DC voltage out. There's a little rectifier that's in the black plug, a little right in there. So you should have close to 24 volts coming in AC, and then somewhere close to that on the DC voltage as well. Obviously, it's going to depend on what your voltage to the rectifier is, what the output is. But if you have 24 volts AC, then you should have 24 volts DC coming out of the plug. Obviously, if you have power coming out and it's still not shifting, then the solenoid in the compressor is bad, and the compressor will have to be replaced. We can't just replace that solenoid. Sometimes you can smack it with maybe a rubber mallet or something and get it to free up. Same thing with your internal overload. If it trips and won't reset, sometimes you can smack it with a rubber mallet and reset it. But more than likely, it's going to trip again. So if it happens, you'll probably have to replace the compressor. So with that, I don't have anything else. If you have any questions, definitely ask now, or you can send it to me directly. Here, I'll get to the end of the slides here, and you can have my contact information if you need it. But I do have some training scheduled for the next couple weeks, so definitely check out our Enertech University site. You can sign up for some trainings. I think I got a WV, variable speed water-to-water training coming up, and then some heat of extraction and some refrigeration diagnostics, things like that. So keep checking out the Geothermal or the Enertech University site. I try to update those at least a couple weeks before those trainings come in, and then if you miss a training, these are always recorded. It says, why doesn't Enertech recommend having an expansion tank on a closed ground loop? Now, if we don't have a problem with expansion and contraction on a closed loop, we wouldn't need an expansion tank. Now, if we do have a problem with, sometimes we have larger loop fields, and for some reason they expand and contract more often, maybe because they've got larger pipe or what have you. But we do have what we call a pressure battery that you can install in the ground loop, and it's a PE type tank, and it's got a bladder, and it's basically an expansion tank. It's just holds some fluid in the backside, and then when it needs more pressure, it just pushes that out. A lot of times with the expansion tanks, we have a problem with them leaking and things like that, with the ones that are more for plumbing. And so I think that's more of why we don't recommend that type of expansion tank. But we do, if you have that issue, we do recommend We call it a pressure battery is basically what we call it. You're very welcome. That's a good question. I normally bring that up, and I've got one of my other trainings. I think we talk about it a little bit, so I probably should put it in here as well. But again, thanks again, guys, for joining. I really appreciate it, and hope you got at least a little bit out of it. And again, check out my other trainings. Have a great day, guys.